Hello everyone, Luke McElfresh here. The purpose of today's video is to go over some practice problems from our Chapter 5 material, which covers the time value of money. So in this particular chapter, we learned that a dollar today is worth more than that same dollar at some point in the future, because if I have the dollar in hand today, that dollar has some type of earnings capacity. What that means is that if I have the dollar in hand today, I could invest it into some type of project or some other savings mechanism, which would generate additional earnings. So anytime I am expected to receive some cash flow in the future, I need to discount that cash flow back to a present value to understand what its true meaning is. And in this chapter, we also discuss how to take a cash flow in current times and figure out what it would be worth at some point in the future if I know the number of periods that I'm compounding that cash flow and also what the given interest rate is. So, in this chapter, there are two different PowerPoints. One that solves these problems algebraically and another that solves these problems using a financial calculator. If we are solving these problems algebraically, there are two main equations that we're using. The first being solving for the future value. So solving for the future value of a single cash flow says we take whatever that cash flow is in time period 0, so its current value, which is represented as present value, and we multiply it by what is called a future value factor. The future value factor is 1 plus r to the t power, where r represents the interest rate per period, and t represents the number of periods in which we are investing that cash flow. The other equation for this chapter is simply solving for the present value portion of the future value equation, which states that to calculate the present value of some future cash flow, we take whatever the future value cash flow may be, and we do what is called discount it back to a present value. We discount it by dividing it by that future value factor, which oftentimes is referred to as the present value factor, which is just 1 over 1 plus r to the t power. So as we go through these calculation examples, I will solve them both using the financial calculator, which is a TI BA2 Plus financial calculator, and I'll also showcase how you will get the exact same answers if you utilize these two equations. And then as we progress through these practice problems, I will solve them using just the financial calculator, as that is the preferred method for this course. So, number one, the first thing that you need to identify are these different components of these two equations. So number one says, what is the present value of $100 to be received in 5 years? Assume a 3% discount rate. For these cash flow problems, I highly recommend utilizing a timeline. A timeline will help you visually see what the timelines are, or what the cash flows are. So in this case, we are expected to receive a $100 cash flow in 5 years. So what we have is 5 different periods that we will need to take this $100 cash flow and discount it back to a present value. The interest rate that we will be using as our discount rate is 3%. So using our present value equation, the present value is what we are solving for. The $100 is the cash flow that we are discounting back, and we divide that by 1 plus the interest rate in decimal form, which would be 0.03, and I need to discount it back 5 periods. So when I do this calculation, what you'll see is you would get an answer of $86.26. What this means is that if I were expected to receive in 5 years $100 cash flow, if my relevant interest rate is 3%, that cash flow is only worth $86.26 to me in current value terms. Now you can also solve this problem using a financial calculator. With a financial calculator, you have 5 buttons on your time value of money row. You have present value, you have future value, and then you have payment, N, and IY. I always group these 3 together as they all need to be input in on the same basis. So when I say the same basis, I mean the same time period. So if it's monthly compounding, all of those values would need to be input in as a monthly basis, semi-annual compounding on a semi-annual basis, annual compounding on an annual basis, and so forth. So present value is what we are calculating for. Future value equals $100. We have not introduced a payment function yet. That will be introduced in the next chapter when we are dealing with annuities. Essentially, when you use the payment function, that would represent a constant cash flow that occurs every single period for whatever you input in as your N. In this case, N is your total number of periods, which is 5, and your IY is your interest rate per period, which in this case is 3%. So when you're inputting these into the financial calculator, what you'll do is you'll type in the 100 and then you will hit the future value button on that third row of buttons on your financial calculator. You will hit 0 and then hit payment. You will hit 5 and then hit N. You will hit 3 and then hit IY. And when you want to compute present value, you will hit CPT and then you will hit present value, and you should get the exact same answer of $86.26. Now moving on to problem number 2. Again, you're just trying to identify what is the cash flow, what are we solving for, what is the relevant interest rate, and how many periods do I need to adjust this? So what is the number of discounting or compounding periods? So again, a timeline could be very beneficial. So what is the present value of $200 to be received in 3 years? So what I have is a 3-period timeline with a cash flow of $200 that needs to be discounted back 3 periods to calculate the present value in time period 0. So once again, you can solve this both algebraically and with a financial calculator. Solving it algebraically, I have the present value equals the $200 that I will be expecting to be receiving in 3 years, divided by 1 plus my interest rate, which is 7%, and I'm going to be discounting that back 3 periods. When you do these calculations, you should get a value of $163.26. Again, we can solve this on our financial calculator, where we have present value and we have future value, and we also have payment, N, and IY. Again, I group these 3 together as they all need to be input in on the same basis. This whole same basis portion of these problems will become a lot more influential or a lot more important when we end up dealing with problems that have compounding that occurs more than once a year. In this particular chapter, most of your problems deal with annual compounding, but as I mentioned previously, in the next chapter, we will start dealing with compounding that occurs more often than once a year. So once again, we are solving for present value. Our future value is $200. We do not yet have a constant payment that occurs every period, so our payment is 0. The N is 3 years, and the discount rate is 7%. Once again, when I solve for the present value by hitting CPT, compute present value, I should get the same 163.26. Now, one thing that I did not mention is that this is most likely coming out as a negative value. This is still a positive value, but your calculator must have present value or future value representative as a negative value. So essentially what this is saying is if I invested, which would be a cash outflow, $163.26, and I invested this for 3 years and earned a 7% interest per year, at the end of these 3 years, that future value of the $163.26 would equal $200. So there would be a cash outflow of $163.26 and a cash inflow of $200. Now, for number 3, you can see that we are solving for the future value of $100 in 4 years. So now we are solving for the future value. Again, I'll draw a timeline just to showcase what these cash flows are. So in year 0, I'm going to invest $100, and I'm going to do so for the next 4 years. I want to know how much will I have at the end of these 4 years if I can earn 8% per year. Using our future value equation, you will figure out that you take the present value, which is $100, and we multiply it by that future value factor, which is 1 plus r to the t power. R being 8%, which I input as decimal form, and since I'm compounding this 4 periods, my t is 4. When I do this calculation, I end up getting a value of 136.05. Let's do this on the financial calculator as well. Present value, future value, we have payment, we have N, and we have IY. Again, I would like you to get into the habit of putting these all together just so it makes the next chapter a little bit easier. So present value is $100, and I want to represent this as a negative value, assuming that I'm investing $100, so it would be a cash outflow. Since I list that as a negative value, my future value will come out as a positive value, meaning that if I invest that $100 at the end of the 4 years, what could I expect to receive as a cash inflow at the end of this 4-year period? We still don't have a payment. My N represents 4 as it's a 4-year investment, and the interest rate per year is 8%. You'll find out that you get the same future value of 136.05. Let's do one more. I'm just going to go ahead and do this 4th one on the financial calculator, where I have present value, future value, payment, N, and IY. it might be beneficial to pause the video at this point and see if you can have the correct inputs and match it up with my solution here. But the present value would be the $200 that I would be investing. I'm solving for the future value. My payment is still 0. I'm investing this for 9 years. My relevant interest rate is 5%. When I solve for the future value by hitting CPT, future value, I end up getting a value of $310.27. Okay, so that is essentially some pretty basic time value of money questions where we are taking either a cash flow in current period value and figuring out what it will be worth at some point in the future, or taking a future cash flow and discounting it back to a present value to see what it's worth in today's terms, since I'm having to wait some time period. Let's take a look at number 5 here. I just inherited $500 and I would like to save it and put it away for retirement. I invested to earn a nominal 7% rate of return with annual compounding. The word nominal just simply means it has not been adjusted. You'll figure out, we'll discuss this more in Chapter 6, where we have compounding that occurs more frequently than once a year. But we have annual compounding. We want to know how much will my investment be worth 30 years from today. So once again, a timeline could prove to be very beneficial. Here I'm investing $5,000. I'm going to represent it as a cash outflow since I'm investing it. It might have been wise to do this also in number 3 here, add the negative sign there to showcase that it would be a cash outflow. And then this is going to be a 30-year period where each year I'm earning 7% on my investment. I want to know how much will I have in future value terms at the end of this 30-year period if I invest it for 30 years at a 7% rate of return. So I have present value, future value, I have payment, I have N, and I have IY. My present value is the negative $5,000 I am investing. I'm trying to solve for the future value. Again, these are all going to be input in and on an annual basis. I do have some practice problems here at the end that deal with compounding more frequently than just annually. My payment here is 0. My N is 30 years, and I'm earning 7% per period. When I calculate the future value, I get a value of $38,061.28. Okay, so those are our present value and future value calculations. Sometimes in finance, you may want to know what type of rate of return you have received. Actually, I think I might have... okay, yeah, this next problem does deal with calculating the rate of return on an investment. So I invested $20,000 today, and I expect it to be worth $1 million in 25 years. I want to know what rate of return did I get over this 25-year period. So again, drawing the timeline will showcase that in year 0, I invested $20,000. Then in 25 years, this $20,000 investment has grown to $1 million. I want to know what rate of return did I earn on an annual basis on this $20,000 initial cash flow, in which it was able to grow to $1 million at the end of this 25-year period. So if I were to go back to my equations here, I have the future value amount, I have the present value amount, the T represents the 25 years, and in this case I would actually be solving for the R. I am going to showcase how to do this on the financial calculator. So here I have present value and future value, payment, N, and IY. The present value is the $20,000 that I initially invested. It has grown to $1 million. I have not incorporated the payment function yet, which is once again whenever there is a constant cash flow that occurs every period that I put in for my N, which in this case my N is 25, and then I'm solving for the IY. So when I solve for the interest rate per year that I have earned, it would have been 16.94%. And I realize I'm going through the solutions here relatively quickly. It might be wise for you to pause, try it out on your own on the calculator, and then just check your solutions with these to make sure that you're getting the same answers as I am as we go about solving these different problems. Number 7. When you purchased your car in September 2007, the list price was $23,500. In September 2014, the list price was $17,500. What was the annual change in selling price? So once again, I'm solving for that growth rate, or that IY, in the change in the price. The one thing that's important to notice is that it went from $23,500 down to $17,500. So in this particular case, the value has decreased, meaning that I should receive a negative IY, or a negative annual change when I do my calculations. Once again, present value, future value, payment, N, and IY. The present value is what I purchased the car for, which is $23,500. I'm going to represent that as a negative, since it would be a cash outflow when I purchased it. And then I sold it for $17,500, which would be a cash inflow, so I represent it as a positive value. In this case, I still don't have that constant cash flow that's occurring every period that I put in there for the N. That, again, will be incorporated in Chapter 6 when we start to deal with annuities. And then our N in this case is the difference between 2014 and 2007, which is a total of 7 years. When I solve for the IY, I should get a negative value. As we mentioned previously, I do indeed get a negative 4.12%. Now, in number 8, I know that I'm expected to receive $30,000 at graduation in 3 years. So this is 3 years in the future, and I plan on investing it at 8.25% until I have $192,000. How long will it take? So in this case, I'm solving for the N. For this particular timeline, the cash flow actually occurs in year 3. It's not going to impact our N calculations, but it is nice to kind of visually see what this cash flow, or what this timeline looks like with the cash flow received at some point in the future. This will be a little bit more important as we progress through the semester and really understanding when cash flows actually occur. So in this case, I'm solving for how long it would take to end up getting $192,000. What should I include in this that I have not yet included? Maybe include that negative 30 since I'm investing that. And for each year, I am earning 8.25%. So once again, I have present value, future value, payment, N, and IY. My present value is the $30,000 I am going to invest. The future value is the $192,000 that I wish to have. I still don't have a payment. The N is what I'm solving for, and the IY is 8.25%. When I solve for the N, I end up getting a value of 23.42. What is this in terms of actual time frame? It is 3.42 years, since everything over here was input in on a yearly basis. Okay, so that covers most of your practice problems, or in your homework and your quizzes for Chapter 5, but I did want to do a couple problems that have compounding that occur more frequently than once a month. So this will be beneficial as we go about moving into Chapter 6, when we start to incorporate compounding problems that compound maybe daily, monthly, quarterly, semi-annually, as opposed to just the annual compounding that we've done so far. Again, the key is to first identify what you are solving for. So in this problem, it says, I invested some money in a fund 7 years ago that offered a fixed 5.99% nominal interest rate, meaning that it has not been adjusted with quarterly compounding. So it's 5.99% per year, but we don't get 5.99% per quarter, okay? So the nominal interest rate is what is called a simple interest rate. It is the interest rate per period, where in this case it's going to be the interest rate per quarter multiplied by the number of compounding periods, and that is how we get that nominal interest rate. So you'll see what the interest rate per period is when we go through our calculations. We are able to draw out $10,845 at the end of this 7 years, and we want to know how much was the amount of your original investment. Hopefully, as you read this, you know that we are solving for the present value. How much did I start with in order to have $10,845 at the end of this 7 years? One thing that might be nice, again, would be drawing a timeline. In this case, in time period 0, I'm trying to solve for this amount. And then in this case, I have $10,845 as my future value at the end of this 7 years. However, this is quarterly compounding, so it's compounding 4 times a year. So in between this first period, I'm going to end up having 3 different compounding periods with another one there at the end of that first year, for a total of 4 compounding periods per year. So as I go ahead and plug this into my financial calculator, I need to adjust all my payment, my N, and my IY, and these all need to be inputted in on a quarterly basis. Okay, let's see how we end up figuring what these inputs are. The payment is still 0. I do not have a cash flow that's occurring every time period for whatever I put in there for the N. So the N is 7 years, but it compounds 4 times per year for a total of 28 compounding periods. Now, as I mentioned, the yearly rate is 5.99%, but it's compounded quarterly, so as a quarterly return, I end up having a quarterly interest rate of 1.4975. Now, there are decimals that come after this 4.975, or values that come after that 1.4975. In order to make sure that the full decimal is stored in our financial calculators, here are your steps. You want to first type in 5.99 divided by 4 equals, then you should hit the IY button. When you do it in that manner, you end up storing the full decimal as opposed to this rounded value that I have here in the solution guide. Okay, let me just try to... Okay, having some trouble deleting the highlights. But anyway, when I solve for the present value here, you end up getting a present value of $7,152.86. If you were solving this algebraically and you had our equation, I'm going to do this one up here. Present value equals the 10,845, and then just like on our calculator, you need to input this stuff in on a quarterly basis. So it would be 1 plus 0.0599 divided by 4 raised to the 7 times 4, or the 28th power, and you will end up getting the exact same present value, whether you're solving it algebraically or with the financial calculator. But your algebraic equation is the exact same way, where you need to plug in everything on the same basis. Again, the same basis just means annually, semi-annually, quarterly, daily, whatever that compounding period or compounding frequency may be. And then last up, number 10, in 3 years, you decide you will want to invest $2,200 in the OU Credit Union. I'm investing it for 12 years. How much would I have if they offered 6% interest per year compounded monthly? In this particular problem, we have 2 things that we need to pay close attention to. One, we are waiting 3 years until we make our investment, and we also have monthly compounding. So if you're confused on how many periods to actually compound this, draw the timeline. So in year 0, I'm not making any investment. It is not until year 3 that I'm investing $2,200 in the OU Credit Union. I'm going to invest this for 12 years. So I have here for the next 12 years, I want to know how much then will I have at the end of this 15th year. Even though it's at the end of the 15th year, I'm only investing this for a total of 12 years. So my N is still going to be 12 years, but I have monthly compounding, so I need to adjust my equations or my inputs accordingly. So I have present value and future value. I have payment, N, and IY. And again, I group these together because these all need to be input in on a monthly basis. The present value is the negative $2,200. I'm solving for the future value. I don't have a constant payment that's occurring every time period that I put in there for the N. I'm investing this for 12 years, but there's monthly compounding, so there will be a total of 144 compounding periods. The interest rate per year is 6%, but compounded monthly, I need to divide it by 12, so the interest rate per period is going to be 0.5%. When I solve for the future value, I end up getting a future value of $4,511.65. Okay, so this covers most of the problems that you will encounter for this Chapter 5 homework and quiz. So hopefully this will provide enough insight and supplemental information to help you be successful on these different assignments. Important to just remember that with your payment, your N and IY, they all need to be input in on the same compounding basis. whether you are solving this algebraically or with the financial calculator. One thing that I did not mention yet is that you can also solve these utilizing Excel. So your Excel functions are actually listed in that Chapter 5 PowerPoint. It would be the exact same, it would be the Chapter 5 PowerPoint that deals with the calculator, not the formulas. But it's the exact same setup where we have similar inputs, except you're utilizing Excel. So if you want to utilize Excel for these, that's more than fine. You'll get the exact same answers. We just don't have our solutions solved in Excel for your viewing. So if you have any questions as you complete this chapter's assignments, don't hesitate to contact me, and good luck.